Welcome back to another video. We are going to take a look at rectangles with equal perimeter in this lesson. I'm on page 128, 129 of your textbook if you're following along. Goal for this lesson, what I want you to get out of it. I want us to be able to draw different rectangles with the same perimeter. Right? I give you a perimeter, you give me all the rectangles with that perimeter. Okay, recognize that the same perimeter can have different shapes to it, different rectangle shapes, which also results in different areas. So a lot of drawing rectangles. We're just going to draw, but then recognize how perimeter plays a role in that. So if you look on page 129, okay, I just redrew it. I like it a little more organized. So all of the rectangles on that page have a perimeter of 18. Okay, but if you notice, they all have a different structure, a different different shape of rectangle. So in this top one, we've got a width of 1 and a length of 8. We've got a width of 2 and a length of 7, a width of 3, a length of 6, a width of 4, and a length of 5. If you add all those up, it's going to result in a perimeter of 18. I have a chart here showing that. So we've got lengths, we've got our widths, and we have our perimeters. Perimeter stays the same at 18. But despite having that same measurement, they all look different. They're still rectangles. They just have a different structure to them. Okay, what that ends up changing is the area. Okay, so this top one, we've got an area of 8 centimeters squared. This second one is 14 centimeters squared. Next one is 18 centimeters squared, and this one is 20 centimeters squared. Okay, so if you want to change the area of something, just change the side lengths. You could have the same amount of perimeter, but overall it looks different. Okay, where this comes in handy is if you want to build something like a patio, a garden, a dog run, something like that, you can either maximize or minimize the amount of space you have inside that area. Okay, I'll use a dog run for an example. Okay, so if I have a set amount of material, right? I have 26 meters of fencing. I want to be able to maximize the amount of space my dogs have to run, so I need to make the right kind of shape for that. If I have a certain amount of material, I need to build a garden, but I don't like gardening, I'm going to try to minimize the amount of area I have, the amount of space I have to build that. So if I use these as an example, if I wanted to build a good dog run or a good deck or something like that, I want to maximize the amount of area I have. Okay, so if you pretended this was 20 meters squared instead of 20 centimeters squared, this is the kind of shape I would want for a deck or for a dog run or for a backyard, something like that. Okay, if you despised gardening, I quite like it, but if you despise gardening and you have to build a garden for some reason, you're going to want something like this where you have the same amount of perimeter, okay, 18 in this case centimeters, but you minimize or have the smallest possible area, so only 8 centimeters squared. All right, hopefully that makes sense. So that's kind of the reasoning behind it, that we can change the amount of area, we can maximize or minimize space by changing the dimensions or the length and the width of those rectangles. Okay, so just below this, I'm going to pop out another example. So if I give you 12 centimeters as a perimeter. Oh, I just realized you can't really see the bottom of that. There we go. All right, so if I have a perimeter of 12 centimeters, I want to maximize, minimize the space, I want to figure out what's best for whatever situation. Okay, I'm going to start by drawing a width of 1. Okay, draw out my rectangle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Alright, and then I'm going to go a width of 2. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Alrighty. Okay, then I'm going to go to I'm going to have to go up a little bit here. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 10, 11, 12. Perfect. Go to with the 4. 1, 2, 3, 4, 5, 6, 7, 8. Got to be careful here. 8, 9, 10, 11, 12. 9, 10, 11, 12. Perfect. I'm going to stop there for now just because I don't have a ton of space. Alright, so we got length, we got width, we got perimeter, and we have area. I'm going to swap to a different color here so hopefully you can see better. Alright. Okay, so our perimeters, thankfully, are all the same. 12, 12, 12, 12. I'll extend this if I have to. Okay, so this top one here, I've got a width of 1, length of 1, 2, 3, 4, 5. Second one, we've got a width of 2 and a length of 4. Then we have 3, 3, and then we have... Now, perhaps you just noticed the same thing that I did. If I write this out, does that look familiar to anybody? Okay, it should. These two are the same. They're just flipped. So this shape and this shape are the same rectangle. One is facing this way though, and the other is facing this way. Okay? So that's how you know, when you reach that point, that's how you know you have figured out absolutely every single rectangle with a certain perimeter. Okay, so I can get actually rid of this because no matter what, I'm going to have an area of 8. And sure, it's facing a different way, but that doesn't mean it's a different shape. It's just facing a different direction. The orientation has changed. Okay. So I've got an area here of 5 centimeters squared. And I did that one already, and this one is 9 centimeters squared. Okay, you're going to get used to doing charts. There's lots of charts in this. It's the easiest way to keep track of your information. Okay, so we took this one out. We got rid of that. Okay, so for a perimeter of 12, there are 3 rectangles that I could draw. Okay, I got this one, this one, this one. This one here is quite possibly the most important because it's going to give you a key piece of information. As you get wider widths, okay, we start with a long skinny and we end up over here at this square, which is a rectangle, don't forget that. Okay, when you hit that square, the next one is going to be a flip of one you've already done, okay, which was the case. So we went from a 4-2 to a 2-4. So I know I've finished all of them. Okay, our long skinny is our smallest area, right? At 5, our square is the biggest area with 9. So again, if I hate gardening, that's the one I'm building. If I love having barbecues, I want a big patio, big porch, that's the one I'm building. Okay, so just keep in mind that square means big area, long skinny means small area, but they all have the same perimeter. In this case, it's 12. In the case of the chart up here, they all had the perimeter of 18, but the areas changed, the shapes changed a little bit. These charts here, I know some of you don't like doing charts. It's extra writing. However, it keeps you organized, and it can help you see things like the 4-2 to the 2-4. Okay, where we had that flip, the opposite orientation. So using those charts is going to be very, very beneficial. If you look through the practice questions on page 130, 129, 130, you'll see that it asks you to sometimes to draw a rectangle with the smallest possible area, or to draw a rectangle with the biggest possible area for a certain perimeter, or to draw every single one of them. Having a chart like this, if you are not super comfortable just pulling numbers out of thin air, doing a chart like this and actually going through and drawing all those rectangles, while it might take you a little bit longer, it'll give you a better understanding of how these rectangles can change, even though you are keeping the perimeters exactly the same. Okay. So if you look at question number 4 in your practice questions, I'm going to do that one for you / with you, and I'm going to do it without drawing too many rectangles. Okay, so it says, suppose you want to make a rectangular garden with a perimeter of 24 meters. A. The garden must have the greatest possible area. What should the dimensions of the garden be? So dimensions are going to be your side lengths. Alright, so what's the length? What is the width? So I'm going to quickly write down what's the information that I need. I need a perimeter of 24, I believe it said meters. Doesn't make sense to have a 24 centimeter perimeter. Okay, so we've got a perimeter of 24 meters. So where do I start with a question like this? Do I just guess? Do I put random numbers? Okay. So I like starting with just drawing some basic rectangles. Start with a perimeter of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay, you'll notice that I'm not super duper worried about these rectangles being neat. Okay, I need to figure out how big that rectangle is going to be. So I have a width of 1 meter and a length of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 meters. Okay, which results in a perimeter of 24 meters. That area, I'll just put it over here, is going to be 11 meters squared. All right. Is that the biggest area? Is it the smallest area? Okay, if you remember back, if we got long skinny, it's going to be the biggest possible area. Now, I can go to the next one. I can draw 2 wide. I can draw 3 wide, 4 wide, 5 wide. Okay? I'm going to skip a few. By using a chart, because I am comfortable with just doing this with numbers. You might not be yet. You might need to draw them all. So if I have a width of 1, a width of 2, a width of 3, a width of 4, a width of 5, a width of 6, I'll stop there for now. I can do the math in my head, so I'll do a little bit of fast forwarding work. Back in a second. Alright, I drew really fast. So, here's a list of all the possible rectangles that this could be. There's an actual picture of all of them. Okay, so I am looking for a garden with the greatest possible area because I like gardening. So if I look at all of these, okay, we have an area of 11. We have an area of 20. That's a big jump. 27. 32. 35. 36. This is all in centimeters squared. Okay. if I really like gardening, I want the biggest possible area, the most possible space. I am obviously going to go for this one. Okay, this 6 by 6, which happens to be a square, which is great. If I add up the perimeter, 6, 12, 18, 24, I still have a perimeter of 24. Okay, if I hate gardening, I don't like gardening, which is question B. If I don't like gardening work, why would I pick the 11 by 1? Because it has the smallest area by quite a bit too. I gain a lot of space, a lot of area if I move up to this 6 by 6. All right. These other ones, there's nothing wrong with them. They're not bad shapes. I'm just looking in this case for this question for the maximum and the minimum area while keeping the same perimeter, which happens to be 24. All right, so that kind of gives you a baseline of how to draw them, how to use your tables, your charts, length, width, perimeter, area. It all ties together here. So what I will get you to do is a few practice questions. Okay, on page 130, have a look at and try 2, 3, 6, 7, and number 8. Okay, there will be dot paper like I use on Google Classroom, so you can download some, print some off if you don't have any at home. Grid paper works fine. I've included some on Google Class as well. Use whatever you're most comfortable with. I'll be back with a review of all the questions that you're about to do. Have fun.